So this question is the second question in 2016 AP Chemistry free response. There are some stuff that's not fair game because it's acid based, but I'm going to go over all the sections anyway because I think it's worthwhile to discuss them, and this way you can make more sense of the parts of the question, which you should be able to do. So the first two A says to identify the type of reaction. This is not fair game because two of the choices are redox and acid base, both of which would not have been covered um, because they're in units 8 and 9 respectively on the in the curriculum guide for AP Chemistry. However, what I hope some of you see right off the bat is that is a weak acid right there, and it's losing its hydrogen and forming sodium acetate. Since it's losing its hydrogen, and the reason why it's happening is because you're actually making H2CO3 here, but H2CO3 is carbonic acid, and it tends to decompose into water and carbon dioxide. Most students are not going to get that, but you should at least see something's losing a hydrogen, and if you assign oxidation numbers, they're not changing. Um, and there's no precipitate, obviously. There's no solid on the right-hand side. So moving on from that question, based on the information, identify the limiting reactant. Now that you should be able to do. It doesn't matter what type of reaction is. Stoichiometry is stoichiometry is stoichiometry, and solution stoichiometry is a legitimate question on the AP exam for you right now. Remember, molarity times volume is going to give you the number of moles. They gave you the mass of one reactant, and for another one, they gave you the other one. So they give you the mass of the sodium hydrogen carbonate, and they give you the volume and the molarity of the acetic acid. So you've got the two things. You've got a balanced equation, I believe, already, and the coefficients are 1 and 1. So this is kind of very easy stoichiometry because the coefficients are 1 and 1. Okay, determining limiting reactant should be easy. You could even do this with a sentence. Okay, as long as you have the moles of both reactants calculated properly. Based on so C says the student observes bubbling and is rapid at the beginning and gradually slows. They said explain this change in terms of collisions. Okay, look, if the bubbling is slowing, what's happening to the number of collisions? Okay, and why is that? All right. Notice the one-sided arrow here. The reason why this arrow would just not illustrate equilibrium is because the gas is being allowed to escape. So this won't reach equilibrium, which tells you what's going to happen to the concentrations of reactants over time. And you should be able to then talk about that in terms of collision theory. All right. Then D, it says in thermodynamic terms, a change can be driven by enthalpy, entropy, or both. Okay, this would not be on the AP exam now, but again, I'm going to go over it. All right. So the question is it enthalpy, entropy, or both enthalpy and entropy? It says the reaction vessel gets cold, which means the delta H is a positive value. The fact that the delta H is a positive value indicates enthalpy is not the driving force. For enthalpy to be the driving force, it would have to be exothermic. So remember, something that's thermodynamically favorable, that's always favorable, has a delta H that's negative and a delta S that's positive. We know that delta H is positive. So if this is going to happen, it has to be a situation in which both signs are the same, which means if the delta H is positive, delta S also has to be positive. And a positive delta S means an increase in entropy, which would be thermodynamically favorable. So I'll tell you right now, only one of these two variables is driving the reaction. You should know which one it is. Now, when drawing a molecular structure of any acid, and I don't know that this is fair game, but I would expect you to notice hydrogen can't be in the middle. And we're not going to see long chains of atoms here, okay? You're going to have carbon in the middle. And in any acid, good little fun fact to know is the hydrogen, the acidic hydrogen will always be dashed to an oxygen. That's why acids can always dissolve in water and they can always hydrogen bond, except for like the binary acids. All the oxy acids are capable of hydrogen bonding to water. All right? So that should be a start off on your thing. Now it says the third carbon to oxygen bond is longer than the other two. Two of the carbon oxygen bonds have the same length. The third is longer than the other two. The hydrogen is bonded to one of the oxygen atoms. Draw the Lewis structure to the best of your ability. This is clearly going to be a resonance situation. I'm going to leave you to figure it out, okay? But do it the right way, and don't forget the negative charge, because otherwise you'll have an odd number of electrons. The last one is, again, a situation in which this is basically a buffer. There are equal concentrations of this and this. So you would have known this is an acid-based solution just on the fact they started talking about buffers and pH here. At that point, you would have gone back to A and figured that out. The solution is measured to be 4.7. Okay, it adds 2 drops of HNO3 and stirs the sample. Observe the pH is still 4.7. Why? You have equal concentrations of a weak acid and its conjugate base. Okay, if you wanted to draw the net reaction, you'd have the strong acid reacting with the conjugate base to make the weak conjugate acid. and the anion for the strong acid. Again, that's a question that would not be on this AP exam. However, I felt I should go over. I'm stopping there.